Okay, so today we're going to start chapter 5. We're going to cover section 1, and we're going to learn what the mid-segment theorem is. So the definition of a mid-segment is going to be a segment that connects the midpoints of two sides of every triangle. Every triangle is going to have 3 mid-segments. So notice in my triangle here, I've got 3 points that are hitting the midpoint of each side. So M would be the midpoint of AB, P would be the midpoint of BC, and A, the midpoint of AC is N. Now, to create a mid-segment, what you're going to do is you're going to take each of these points, these mid-segment points, and you would connect it with another mid-segment across from it. So we would have 3 mid-segments in each of our triangles. So notice when we create the 3 mid-segments, it makes another little triangle inside. The way that we can tell that point M is a midpoint is notice that we have congruency marks here. So I can tell that it's splitting my segment AB into 2 congruent pieces. And that's all the way around all 3 sides. Next, we're going to talk about the mid-segment theorem. And the mid-segment theorem states that the segment connecting the midpoints of the 2 sides of the triangle is going to be parallel to the third side. So notice side 1 and side 2, that's where the mid-segment is created by hitting the 2 midpoints. And then that mid-segment is parallel to that third side. Also in the mid-segment theorem, it tells us how we can find out the length of that mid-segment. And the length of the mid-segment is going to be half as long as the side that it's parallel to. So for example, let's say I told you that the length of AC, and let me erase these numbers. Let's say I just pick a random number here and I tell you the length of AC is 10. If DE, which is the mid-segment to AC, is half the length, how long is DE going to be? 5. Okay? And if I gave you the length of a mid-segment, let's say I changed the numbers, and let's say I told you the mid-segment length was 4, how much would the length of AC be now? 8. It's that easy. All right? Let's try some. And then another definition before we get to the examples, we're going to talk about creating a coordinate proof. And what we're going to be doing is placing a geometric figure in a coordinate plane. We might be placing a rectangle, a triangle. We've already graphed triangles. So we'll be placing it in a coordinate plane, but instead of getting specific order pairs, our order pairs are going to have, or our coordinates are going to have variables in them. So that way the results would be true for every figure type. And we're going to do an example of this in a minute. But for right now, we're going to do 2 examples of mid-segment. So here it says, this is a real world application, and it says that triangles are used for strength in roof trusses. So in the diagram, and the triangle that they're referring to in the figure here is this one over here. So in the figure, it's stating or telling me that UV is a mid-segment and also VW. These are 2 mid-segments. Now, they want us to find the length of 2 other segments. They want us to find UV in RS. So now, let's go ahead and locate where this is. So let's find out where UV is. It's right here. And they told me that this is a mid-segment. Remember, the length of the mid-segment, it is going to be half as long as the side that it's parallel to. And that side that it's parallel to, the RT, is 90 inches. So how long will be the length of UV? 45. I just take the length of that outside segment and divide it by 2. The next thing it wants me to find is the length of RS. RS is the outside side. And then they're also giving me the length of the mid-segment. So when I have the length of the mid-segment, how can I find the length of the side it's parallel to? multiply it by 2. So I'm going to take the 57 times that by 2, and the length of RS is going to be 114 inches. And same thing with the 45, those were in inches. Look at the next example. Now, I know this is a little bit hard to read at first, but what we're doing here is we're going to do this in rows. So the first row I'm going to take care of is this one. And we want to find the missing measurements. So for this one, they're giving me the outside lengths. So they gave me the length of AB, and they told me that length is 12. They gave me the length of BC, and that one's 14. And then they also gave me the length of AC, and it's 18. So I'm working across row A. So let's go ahead and fill in the length of ST. So if I go ahead and find ST, you can see that it's parallel to the green, and that would be the mid-segment for AC. And we know that the mid-segment is half of the length of that third side. So 18 divided by 2 is 9. Now let's look for RT. RT is parallel to AB. The length of AB is 12. So to find the length of RT, divide by 2, and it's 6. Let's go look for RS. RS is parallel to BC. BC is 14. Divide 14 by 2, and it's 7. Let's go ahead and erase because we're going to change the numbers in the figure. Get rid of those. So now I'm going to work on row B. So B tells me that BC, this one right here, is 15, and AC is 22. Now this time, they're giving me the length of RT, and they told me it was 10. So now we'll go back and let's fill in the chart. So the first thing I'm going to look for is AB. It's parallel to the RT. So I know that the mid-segment was half, but if I'm looking for the outside, I take that mid-segment and I multiply it by 2, making this 20. Next, I'm going to look for ST. ST is parallel to AC. AC is 22. So ST is 11. RS is over here parallel to BC. BC is 15. So RS would be 7.5. Now I'm going to erase the numbers again. And now do row C. So C is telling me that AB is 10, ST is 9, and RS is 7.8. So the mid-segment that's parallel to AB is going to be RT. So if AB is 10, RT is 5. Then I can come back and look for the length of BC. BC is parallel to the 7.8 or to RS. So I'm going to double it, times it by 2, 15.6. And now AC is parallel to the 9. So then I would take 9, times it by 2, and the length of AC is 18. So for example 3, and I'm going to add in a coordinate plane so I can graph this just to show you. So I'm going to put in a coordinate. Okay, so it says to place a rectangle in a coordinate plane so that its vertical side has a length of A and its horizontal side has a length of 2A. It wants us to label the coordinates of each vertex. Now, whenever you do a coordinate proof like this, it's always a good idea to try to position your figure in the origin. It'll help because it'll help you find the ordered pairs a little bit easier. So when I go to place my rectangle, I'm going to go ahead and set up A, and I'm going to have A equal 2 boxes. So the length of A for me is going to be 2 little squares here. So 2A would be, so this would be 2 boxes. 2 boxes for A, 4 boxes is going to represent 2A. You can decide however big you want to make it. Just know that whatever you decide how many boxes are going to represent A, double it for the 2A. So then now I can draw my rectangle. So now I can see that the length of this side is 2A. And now I need to come up with the coordinates or the vertices of each one of these corners. So when you position it at the origin, this coordinate right here is easy. It's 0, 0. So then this coordinate, because it's on the y-axis, is also easy to find. You know, the first number in the coordinate is going to be 0. And because they told us it had a length of A, it's going to be the ordered pair 0, comma A. And then over here, this vertex, again, it's on the x-axis. So the second number in my ordered pair is 0, but we knew it had a length of 2A. So this is going to be 2A, comma 0. Let me move this over. So 2A, comma 0 is that ordered pair. And then the top of the box here, or the top of the rectangle, is going to be the x part is 2A and the y is A. So this is how we could put a figure into a coordinate plane and then just label it with variables as the coordinates. And again, if you place it along the x or the y-axis, and even using the origin as one of the vertices, it makes it a lot faster and easier to come up with the coordinates. So the next example that we're gonna complete. Okay, so this question has a lot involved here. So let's go and do piece by piece. So the first thing it wants us to do is sketch ABC. So I'm gonna sketch these 3 ordered pairs. And again, you can decide whatever length you want to make H. I'm going to let H be a length of 8, so I'm going to count over 8 squares. So the first order pair I'm going to graph is A, it's the 0, 0. Then I'm going to graph B, and first I'm going to graph C, which will be 2H. So if I'm going to let H be, actually I'm going to let H be 4, and then 2H will be 8. So B is going to be HH. So if it's going to represent 4 boxes, 1, 2, 3, 4, 1, 2, 3, 4, my point for B will be here, and this is going to be HH. And then C will be, go all the way to 8, 5, 6, 7, 8. So here's where C will be, and this is going to be 2H, comma 0. Going to connect the points. So then the next thing to do is to find the coordinates of each midpoint. So I need to find the midpoint here, here, and here. And the way that I'm going to do that is I'm going to use the midpoint formula. So if you recall, the midpoint formula is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. That's your midpoint formula. So the first thing I'm going to do is calculate the midpoint of AB. So I'm going to take the coordinates. Let me go ahead and label them in the picture again. A is 0, 0, and then the B is HH. So I'm going to do 0 plus H divided by 2, and 0 plus H divided by 2. So the midpoint is going to be H over 2, H over 2. That's the midpoint of AB. Then I'm going to find the midpoint of BC, which is over here. And again, do the same thing, same formula. So H plus 2H divide by 2, and h plus 0 divide by 2. This will give me 3h divide by 2 and h over 2. I'm going to leave it just like that. For the midpoint of AC, again, take those coordinates, 0 plus 2h divide by 2, 0 plus 0 divide by 2. So I get 2h over 2, and then 0 over 2, and this will just simplify to h comma 0. The next thing, so it wants us to find the midpoint, so I did that. I also need to find the length of each side, so I'm going to use the distance formula for that. So if you recall that the distance formula is x2 minus x1 squared plus y2 minus y1 squared, and it's all under the square root. So I'm now going to calculate the distance for each one of the order pairs. So first I'll calculate the distance for side AB. So again, we're going to plug it into the distance formula. So the order pairs were 0, 0, h, h. So if we do h minus 0 squared plus h minus 0 squared under the square root, h squared plus h squared gives you 2h squared. I can actually square root the h, it will come out, and the 2 stays underneath. So that is going to be the length of AB. I'm going to do the same thing for the length of BC. Again, the order pairs are h, h, and 2h comma 0. 2h minus h squared, 0 minus h squared under the radical. This becomes h squared plus negative h squared, and it just becomes h squared plus h squared, so 2h squared, square root it, and I get the same answer, h radical 2, and that again is the length of BC. Now for the length of AC, I could just count the boxes, and we can see that the length of AC is just 2h. So then now, my next thing that it asked for is to find the slope of each line. So again, I'm going to take those order pairs, and I'm going to calculate the slope. If you recall, the formula for slope is y2 minus y1 over x2 minus x1. Or you could count the rise and the run. I'm going to go ahead and use the slope formula. So the slope for AB is going to be h minus 0 over h minus 0. H over h gives me a slope of 1. The slope of BC is going to be 0 minus h over 2h minus h. So this will be negative h over h, simplifies to negative 1. And then lastly, the slope of AC, that is just a horizontal line. It's going to be 0, but we could also show the formula. 2h minus 0, 0 over 2h, and it did simplify to 0. Let's see what else they asked. They also asked so we found the length, we found the slope, we found the coordinates of the midpoint. Now it's asking me, is it a right triangle, and is it isosceles? So in order for the triangle to be isosceles, we're going to check out the slopes. Remember, a right angle can be formed by perpendicular lines. Perpendicular lines have opposite reciprocal slopes. And if you take a look at AB and BC, these are opposite reciprocal slopes. Okay, so they do have opposite reciprocal slopes. So yes, this is a right triangle. The next thing asked if it was isosceles. So to check to see if the triangle is isosceles, I'm going to go back and check my lengths where I use the distance formula. And notice both AB and BC also have the same length. So yes, this is also an isosceles triangle. And then that completes all of the parts of this question. It's going to be example 5. So here's my figure. I know it's kind of small, but it wants me to find the length of GH. So this is just using the mid-segment again. But again, we've got expressions. So over here, GH is this side, and it told me that GH is 7x minus 1. Then it's also giving me something for its mid-segment, which is BC, and that's going to be 4x minus 3. Now, when we did the problems earlier and they had numbers, it was super easy. We just times it by 2 or divided it by 2. I'm going to do exactly the same thing here. I'm just going to take this 4x minus 3, and I'm going to multiply it by 2 and set it equal to the outside edge. All right, all you do is set it equal to the 7x minus 1. I'm going to distribute. And then I'm going to move my x's together. And I get negative 1 equals x minus 6, add 6, and x equals 5. I'm going to plug it back into GH, which was 7x minus 1. So 7 times 5, 35 minus 1. The length of GH is 34. And then here is example 5.